Okay, so we are learning from home. I just wanted to make a couple of comments here before we get started for today. We are in week 8. So tomorrow we'll be in the half mark of the season. But just getting into week 8, I don't know if I did this, but I wanted just to kind of say I was kind of a little off adding into this little page here, but I wanted to indicate week 8, an individual, and I apologize if I mispronounce his name, but Siabolela Zuez. Help me out, please. But I found this individual who is a South African scientist and engineering, energy engineering, and he graduated from Harvard. But what's so nice about this is that, he's the youngest member in Africa to be on the energy advisory panel. So I thought that was pretty cool. And I just want to say awesome job, and to the bonus points that you did. The timeline came out amazing. So good job to those players that participated. Getting back into the module, I did some changes. So I just want to make sure that we're all on the same page here. Always that you have your SI sessions. But this was a good quote. The strongest factor for success is self-esteem, believing you can do it, believing you deserve it, and believing you will get it. And so this week you have a D8 and you have a O8, but you will not have a reflection. So you won't have a reflection every week, and I will indicate that. This week we're going to finish up 2.7, get into the 2.8 and 3.1. We're going to bypass 3.2 for now and get into the 3.3. And then next week is week 9. So we will be having a drill 2 that will focus on 2.2 up to 2.6. And then game 2, week 10, that will have 2.2 to 2.8 and these 3 sections of 3.3. If I don't cover 3.2, I don't know why I put that there. I didn't want to put 3.2. So I'm 3.3, I meant 3.4. Well, let me see how Wednesday lecture goes. But the new thing that I added here are some handouts for 2.7, 2.8, 3.1, and 3.3. And then I'm going to do that on the preview page opposed to the Monday participation and Wednesday participation. Okay, so what's up to bat? So I wanted to take a look here at a question and see. And this is where you need to start timing yourself. So at this particular marker, I'm writing it down, 3.27. I want you to pause and I want you to answer the following questions. Is the function differentiable at 2? Is the function continuous at 2? And justify your conclusion not using a graph. So, when you did your reflection for this week, a lot of individuals were, oh, I use the definition of continuity, but I don't understand why I got the points off. If you do not understand why points are taken off, please see me during office hours so we could correct that, because maybe I made a mistake. It's possible. Or maybe there was something missing from your definition that we need to clarify. And the solutions are available in the game 1 for you to take a look at that. So this is your time to pause. Okay, so I'm going to put my timer on and start. Want to keep track of your time. Now, you also want to pay attention to the directions. So what this is illustrating is that if we find the derivative f prime of x You do not have to use that lengthy definition of the limit if it doesn't ask us to, because we're able to use other definitions. So the derivative using the power rule here would be a 2x if x is less than or equal to 2, and this would be 1 if x is greater than 2. So what I'm looking at here is f prime from the left of 2 is going to equal a -4, whereas f prime from the right of 2 is going to equal 1. And since these do not equal, then f prime at 2 does not exist. And you see how I'm speaking at the same time, but I was able to get that under a minute 20. Now, if this was differentiable at 2, then we could say, therefore, f would be continuous at 2, and that was because of that theorem, right? All differential functions at a are continuous at a. However, since this function is not differentiable at 2, we have to go verify if it is continuous at 2, and that is spot checking. That is spot checking. I did it again. Verifying that the limit as x approaches 2 of my function f of x, does that equal f evaluated at 2? And so in this particular case, when you take a look here at the limit as x is approaching what? 2 from the left, you have 8 minus x squared. Does this equal the limit as x approaches 2 from the right of x plus 2? And so when you evaluate here, you're going to get 4. When you evaluate here, you're going to get 4. So therefore, we know that the limit as x approaches 2, and yes, it's important that you write this function notation here, does equal a 4. And when you evaluate your function at f of 2 here, then 2 here, then you also get 4. So therefore, we just verify that f of 2 equals 4. And so since these are equal, so this justifies this. So therefore, f is continuous at 2. So I'm just pulling this as my reasoning. Stop. Oh, I didn't pause. Oh boy. Oh, anyhow, I was thinking. So let's get into this last example that we were working on last time to see if we found the second derivative correctly. So what this is illustrating here, I'm going to need a little space here, y double prime is going to equal the second derivative with respect to theta. And since this here is a constant, best practice is just to bring out the constant times the derivative. And now we're going to have to use the product rule. And the product rule says that we're going to take the derivative of f. So the derivative of f, we have to use the chain rule. And the chain rule is going to illustrate that this is going to be a minus, and this is going to be a sine. This is going to be 3 theta times the derivative of the inside, which is going to be a 3, times g, which is going to be sine of a sine 3 theta, plus f, which is going to be, we already found, times, so let me back up. So that's cosine 3 theta. Now you're taking the derivative of the outside function, evaluate it at the inside function, and now you got to take the derivative of the inside function again. So that's why we have cosine 3 theta, and then you got to take the derivative of the inside function. And so now we have to clean this up a little bit. And so when you clean this up by distributing this -3 with that negative, then that's going to give me a positive, and that's going to be a positive 9. Then you have a sine, then you have 3 theta, then you have a sine, another sine, 3 theta. My apologies. When I distribute, you're going to get a -9. Then this is going to be a cosine of a 3 theta, a cosine of a sine 3 theta, and a cosine of sine 3 theta is going to be that derivative. And look at here, right? And that's why I say, 8 minutes is just kind of a baseline. And then lastly, I noticed that this is a cosine 3 theta. Let me see this. So when I took the derivative here and here, I added an extra. This one was incorrect because the derivative of sine is cosine evaluated at the inside function. Then you take the derivative of the inside function. So then that should have been a cosine of 3 theta times 3. And so what I'm noticing here when I rewrite this, that when I distribute, so when I distribute here, this is going to make this a -9. But cosine 3 theta and another cosine 3 theta is going to make this a cosine squared 3 theta. And then this would be cosine of sine 3 theta. And that would be my simplified derivative.